So let's now focus in on radio frequency fundamentals, and we're going to start using the terms that we use when we described radio waves within the wireless LAN environment. Radio waves are in a specific area of the spectrum band, and we're going to use those radio waves to send our information over the air. And the way we do that is we're going to represent our ones and zeros in waveforms that transmit at certain frequencies. And then by tuning into those frequencies, we'll be able to receive those signals. It's no different than when you tune the radio in your car and you can hear different radio stations. And so we're going to do the same thing. We're going to transmit at different frequencies, and we're going to represent your ones and zeros in waveforms being sent on those frequencies. So when we think of a waveform, there's three attributes where we describe the wave. One is the amplitude. You can think of this as the height of the wave. Many people like to think of this when they think about an amplifier with their stereo system. So if you listen to music and you want to turn up the strength of the signal, then you put an amplifier in there and you turn the knob and your signal will get much stronger. And what you're doing is you're creating a much larger gain, a much greater waveform. But the other way of thinking about the amplitude that I always like to give to people is, imagine if you were holding a piece of rope and I was holding the other end, and I made these really high up and down movements with my arm, and I said, when you receive this really big wave, that's a 1. And then if I made some really small movements with my arm, such you've got very small waves coming down the rope, then that would be a 0. And therefore I'm using a form of amplitude to represent my ones and zeros. A big wave, a strong, powerful wave, represents a 1. A little dinky wave, not much power, representing a 0. And that's amplitude. So modifying the amplitude, I can reflect and send you ones and zeros, which is effectively just changing the strength of the waveform. The other thing I can do is I can change the frequency. So imagine if you were again that you were holding a piece of rope and I was holding the other end, and I waved my hand up and down really fast, and I said, this really fast wave, that's a 1. And then I waved my arm up and down really slowly, and I said, this really slow wave that I'm forming, that's a 0. And by holding the other end of the rope and receiving the really fast high frequencies and then the really slow frequencies, you would be able to distinguish between my ones and zeros. Now the phase is a little bit harder to understand, because what I'm going to do is I'm going to change the phase of the wave. So imagine, if you would, you're still holding the other end of the rope, and the first thing I do is I move my hand up and then down, and I say, okay, that's a 1. And for the next time I want to send you a waveform, I move my hand down first and I say, okay, that's a 0. Now if you can detect those phases coming in on the receiver, so you can say, okay, I know that Avril moved her hand up, that must be a 1. Oh, now she's moved her hand down, that must be a 0. And that is changing the phase. So I can change the amplitude, the strength of the signal, the frequency, the number of cycles per second that I'm sending down that rope to your hand, or I can change the phase, where I change, did I go up or did I go down first? And therefore by changing the waveforms in these ways, I can distinguish between your ones and zeros. So now you have an idea of how I can change the waveform in order to reflect your ones and zeros, so I can use waveforms to send information over the air. Let's talk about the major components of a wireless system. So the first thing is a transmitter. And so a transmitter is what's actually going to take your ones and zeros and actually create the waveforms such that they can go out over the air at the desired frequency. And this is referred to as modulation. So I'm taking your ones and zeros and modulating them such that I'm creating waveforms which will go out and over the air. An amplifier is just an intermediate device that alters the strength of the signal. Now, if you're very far away, then I obviously will have to raise my power level up in order to get my signal to you. If you're closer to me, then I can reduce down the power. This is very similar to someone shouting at somebody who's on the other side of the field versus someone standing right next to them. They don't need to shout. Now, an amplifier is easy to think about on the transmitting side, but it also exists on the receiving side. When I receive a signal, I may have to amplify that signal before I go ahead and process it. Now, antennas. I love talking about antennas. And antennas are simply electrical devices that take the electrical signal coming from the transmitter and then they convert it into radio waves. On the receiving side, they do the reverse. They take the received radio waves and then convert it back to electric currents and send it to the receiver. The medium, this is what we were talking about a little while ago. This is the physical medium that your signal is going to go out and over. So you're going to radiate your signals from one antenna and they're going to be received at another antenna, and what's in between is what we refer to as the medium. Then of course the opposite of the transmitter is the receiver. This is the device is going to receive those signals from the antenna and then convert them from those radio waves which went to electrical currents, which now have to get back to your ones and zeros. So receiver's just going to take that and try to estimate and guess what your ones and zeros were, and hopefully if we got it right, you'll be able to get your data back. Now, a combination of a transmitter and a receiver is called a transceiver. So on this picture here you can see the term transceiver. So those devices both transmit and receive.